The critical path method or critical path analysis is an algorithm for scheduling a set of project activities. It is commonly used in conjunction with the program evaluation and review technique. The path which takes the maximum time for project completion is what a critical path is. As we have seen in previous lecture, finding a critical path is quite easier thing to do in case of simple network. But when the network gets more and more complicated, numerous routes will involve and hence a computational approach is required. There are two steps to find a critical path via a computational approach: forward pass computation and backward pass computation. We are going to use the same problem as before to understand this. First, we are going to discuss about forward pass computation. Forward pass is a technique to move forward through network diagram to determine project duration and to find the critical path. This is the first step in the calculation. As you can see in this particular figure, here I is the tail event or start event and J is the head event or the finish of the event. That means the head is where the activity finishes. E suffix I is the earliest start time or EST and EJ is the earliest finish time or EFT and Tij is the time consumed in the activity. Also, EI plus Tij should be equal to EJ. Now for backward pass computation, we have a second step in the calculation. Through this pass, the late start and late finish values are calculated. To start the backward pass calculation, the end finish value in the last activity is dropped down to the last finish value. Here, Lj is the latest finish time or LFT and Li is the latest start time or LST. In this case, Lj minus Tij should be equal to Li. These two passes are required to have a detailed analysis in which Ej and Li are the most prominent one. Ej is nothing but the maximum value of all Ei plus Tij and Li is nothing but the minimum of all Lj minus Tij. These values are considered in case of multiple merges. Let's take the same example as before to understand CPM computational approach. Let's take the first step, that is forward pass computation. Here, Ej would be the maximum value of all Ei plus Tij. Now for event 4, there are two routes via 124 and via 134. From event 2, Ei plus Tij is equal to 3 plus 5, that would be 8. And from event 3, 4 plus 5, that would be 9. So this is the maximum value. And hence, we will consider this value for forward pass. For event 5, there are again two routes via 1245 and via 1345. The corresponding values of Ej are 3 plus 5 plus 7, that is 15, and 4 plus 5 plus 7, that is equal to 16. So again we will take the maximum value, that would be 16. Similarly, we can calculate for rest of the events. Now for the next step, we are going to do a backward pass. Here, Li is the minimum of all Lj minus Tij. Here, only for event 4, we have to calculate because other values will come just by subtracting. Now for event 4, there are two routes 754 and 764, whose corresponding time values are 24 minus 2 minus 7, that is 15 for root 754, and 24 minus 10 minus 5, that is 9 for root 764. So the minimum would be taken for backward pass, that is 9, so we will take 9 here. Now we are ready to determine the critical path. The critical path is the one in which Ej and Li values are the same. Or we can say EST is equals to LFT. So by looking into the network diagram, the critical path is QSUW.